Hello and welcome to section 5.6. In this video I am going to just go through and try to remind you of all the things about trig functions from pre-calc class that you learned in maybe Algebra 2 because then when we come to class we'll talk about the differentiation and all that fun stuff. But so you need to remember that arc sine is the same as like sine to the -1 of x, and we're going to go through and it's the inverse when we restrict the domain and the range of the original function. And so remember that the ranges over here are the domains of the original function, and the domain is the range of the original functions, and so we're going to restrict all of these guys as we go through. So just make sure if you don't have this that you get this down so that you can have it. And so we're going to talk about those, and we're going to start by evaluating these, and this is just a reminder from the unit circle. So if we were asking you for where sine of -1/2 is and we want to know the angle, then we use arc sine to represent, we're looking for the angle of sine of -1/2, and so we have to think about the unit circle, and where that shows up is at -pi/6, or some people might call that 11pi/6, and those are the same locations. It's just we're going backwards, so we're just going to use -pi/6 for our representation. And then if we wanted to represent where arc cosine is 0, so we're just asking you where is cosine 0 on the unit circle, well, the first time that pops up is at pi/2. So the answer for this would be pi/2. And then the arc tangent is √3, so we're looking for, in this case, where we would get √3 on the unit circle, and so we're just saying that where tangent would be √3, and so that would be at pi/3. And then for this last guy down here, you're going to have to punch this in on your calculator, and if you were to punch this in on your calculator, let me open up my calculator real quick. And if I'm going to do that, the arc sine button is, remember, second sine, and then we type in 0.3, and we get our, oops, I'm in degrees, check your mode, make sure you're in radians. And so once we get out of that, we can do second sine of 0.3, and we get that number, which is what we were looking for. So 0.305 is really what we would like for our answer for that one. And this is just checking to make sure that we're all in the same spot with using our calculators and just remembering trig functions. So then we have some properties of trig functions, and just remember they're just talking about the inverse. So we're saying that if we were to restrict sine and we did the arc sine of a function, they're inverses of one another, so we end up with x. And if we flip it around, then we'll get y. So this is how, remember we talked about inverses, and when we talked about inverses, when we plugged one into the other, in for the other, we ended up getting the variable that we were using. And so that's all this is really saying. And it basically, I only did I did sine, tangent, and arcsecant, but it works for all the other trig functions the same. It's just the restrictions are a little bit different depending on which function they are. So, you know, we'll just remember that, and that's just talking about inverses. And so now we're going to solve a problem that looks like this, that says, oh, well, arctangent of 2x minus 3 equals pi/4. Well, if I can use my properties, my inverse properties, to remove the arctangent by doing a tangent on both sides. And I probably should rewrite this. So if I do tangent on both sides, I'd say tangent of the arctangent of 2x minus 3 will equal the tangent of pi/4. Well, we should all know what tangent of pi/4 is. That's 1. And so then this tangent will remove the arctangent, so we really have 2x minus 3. So we now have this nice, neat little algebra problem. So we add, oops, getting ahead of myself here. If I add 3 to both sides, 2x will equal 4. If I divide by 2, x comes out to be 2. And that's really what we were looking for our answer for this problem. And then my final example for today is, like I said, this is the last example before we head into derivatives. So we will talk about derivatives in class. And so I just want to make sure that you guys are all up to speed. So then if I'm asking you for, if I say y, we're given that y is the arc sine of x, and we end up having, in this ratio, we want to find cosine of y. So what I'm going to do here is basically I have to remember that cosine, I'm asking to do this, that I want to know the cosine of the arc sine of x. Well, if that's the case, remember that is equal to the adjacent over the hypotenuse, but the problem is we need to first figure out what's going on here, and so that's what I have right here. I have the triangle of y with my angle y, and so x would be my opposite. 1 would be, since we're just using sine of x, then 1 would be my hypotenuse, and in order to get this side I did Pythagorean theorem, and so I did x squared plus y squared, or x squared plus our unknown squared will equal 1 squared, and then I solved and I got this side. So really my answer for this problem is going to be this thing down here, my adjacent to y over my hypotenuse, which means that I get the square root of 1 minus x squared over 1, or the square root of 1 minus x squared. And again, like I said, this is a review from pre-calc class when we did this. And so you need to remember this stuff as we go through, because it's a way to solve some of these problems that we're going to do when we head into differentiation. So then we have the arc secant is root 5 over 2, and so we need to remember that arc secant is the flip of cosine, and if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And since we're looking for the tangent of y, we're looking for opposite over adjacent. And so my triangle will look something like this, that my hypotenuse is root 5 over my adjacent, and if I do Pythagorean theorem, I will find out that this missing side is 1. So then, if my tangent of y will be the opposite over the adjacent, which would give me 1/2. So this concludes our videos for today on this, and we'll talk about the differentiation rules and whatnot when we get to class. So if you have any questions about this, please come to class prepared to ask them.